through stuff this morning, and we've done, other than trig identities, which I really don't want to go back to dealing with again. Um, we've covered just about everything. We've touched on everything at least. Um, so yeah, we'll finish one thing today, and that'll be it for this one too. Have the rest of the week to relax and sleep in a little bit. And, that will wait a sec and see if, I don't know, there's usually some other people that um, show up. But other than that, everything's all finishing, and I got an email earlier. Hey, you're eligible for a new laptop. So I'm kind of pumped about that. Well, it's 10:03. I think I'm recording. The only thing I'm gonna go back to talk about intercepts a little bit. I really didn't want to redo questions, and then talk about the graphs and how we can add and make sure we know where we're going with those intercepts. So we've talked about, for all of grade 11, y-intercepts and x-intercepts. They're useful on graphs because they're points where one of the variables is zero. They're usually easier to solve for. So if we have a logarithmic or an exponential function, we can find an intercept. A y-intercept, we set x to 0. So this is y equals that. So if I want to find an y-intercept, 2 times 3 to the 0 minus 5 minus 8 equals 2 times 0 minus 5 is negative 5. Whoops. These ones are, the y-intercepts are easy and hard. So that's 2 times 1 over 3 to the 5th minus 8. 2 times 1 over 3, 9, 27, 81, 8 3/8 are 24, 243 minus 8, 2 over minus 8. That, oh,
Okay, I can't see the screen.
oh, sorry,
It's okay.
dummy. It's stuff we've talked about. I put 0 in for x, so 0 minus 5, 1 over 3 to the 5th. If you do that out, your y value is negative 7.99. It's a ridiculously large amount of 240 thirds. 799. I'm going to do the y-intercept for the log one here as well. Let x equals 0, y equals 2 log base 5 of 0 plus 3 plus 1. 2 times the log base 5 of 3 plus 1. Now we kind of have to evaluate that. 2 times log 3 over log 5 plus 1. I need my calculator to do this. 3 log divided by 5 log is that, times 2 plus 1. Logarithms, you're going to have to use a calculator. 2.37. And when we graph those in a sec, we'll see where those are. We're not going to be able to plot exactly. A y-intercept, we let x, or an x-intercept, we let y equal 0. 2 times 3 to the x minus 5 minus 8. And now we have to solve for x, which we can do now. 8 Divide that by 2. To get an exponent, log of 4 equals log of 3 to the x minus 5. Log of 4 equals x minus 5 times log of 3. Dividing 4 log divided by 3 log equals 1.26. 6.26. And that has an x-intercept. Typically, if we were just doing an exponential function, it's going to have a y-intercept, but it won't have an x-intercept. But because it has an asymptote and has been translated down, it does. I need the equation for this one. 2 log 0 equals 2 log base 5 of x plus 3 plus 1 minus 1 x plus 3 minus a half equals log of 5 x plus 3. To get rid of this, we raise it to the 5th power. Well, the square root of 5, or 1 over the square root of 5. Oh dear. Because the half gives us the root, the negative gives us the fraction. 1 divided by 5 root equals 0.4445-ish. Minus 3. So there's our x-intercept. A logarithmic function typically has a vertical asymptote. Oh, so that's why that's going to actually exist. So we're going to use those 2 points and look at plotting these 2 graphs. So we had 0 and negative 7.99. Of course, I can't remember the other point. 6.26 and 0. So if we were graphing this, just to remind ourselves, our base function is 3 to the x. So we need negative 1, 0, 1. So a third, 3 to the 0 is 1, so that's 3. This one is going to have a mapping rule. That's a vertical, so x plus 5 to y minus 8. So this is going to transform to negative 1 plus 5 is 4, 5 and 6. 2 ones are 2, 2 minus 2 ones are 2, so that's negative 6. 2 threes are 6. That's negative 2. 2 times a third is 2 over 3. 3 eighths are 24. Minus 22 over 3. I think I did that right. If I try to go quick. 3 eighths are 24. Yeah. Okay. So 4 and that's negative 7 point something. 1, 2, 3, 4, 5, 6, 7. And a third. 5, 1, 2, 3, 4, 5, 6. 6 and negative 2. This one has a vertical asymptote at -8. So I can throw that in there. So my graph, and this is now here's where the fun begins. We have 6.26. Well, there's our x-intercept, which makes sense. Our y-intercept is way over here. Oh gosh. I could put it on the smartboard and draw it better. That's a horrible graph, but we have our y-intercept, x-intercept. If we didn't want to find all the points, if you know those two, you know where the asymptote is, you can draw it and have a pretty good idea. No, wrong way. 237 and -2.55. So base is log base 5, but it's a log. We have that part. Everything kind of gets backwards. Our mapping rule is x minus 3 to y plus 1. So our new table is going to become 2 times -1 is -2. -2 plus 1 is negative 2 zeros. That's a 1. 2 ones are 2, and that's a 3. 2 times -1 is negative. Yeah, that works. 5 minus 3 is 2. 1 minus 3.
Good morning, everyone. I just wanted to let you know that there are a few treats on the front desk in the lobby. Fresh biscuits from yesterday with red jelly pepper. There are ginger snaps. There are a few different kinds of brownies and date squares. Apple sandwiches too, so help yourself.
Minus 2. 1/5 minus 15 fifths is -14 over 5, which is -2.8. So over 2 up 3, -2 and 1, -2.8 and -1, which makes sense. This one, has a vertical asymptote at -3. So we have that business, and this one's a little bit easier to see. 0 and 2.37. Well, let's put that somewhere there. -2.5. So we have our intercepts. This one kind of plateaus a little bit. It's going to come. Gosh. Drawing graphs on this sucks so bad. And we can use our intercepts to do that business. Okay, you guys were able to see all of that, I hope. Sarah and Amy knew this was going to be relatively short. Christian's probably going to curse me and say, why the hell did I get up for this? But there's other things that we didn't kind of talk about, applications of things, word problems, and all of that. But the whole goal of this was to give you the bare bones. Here's the algebraic skills that you're going to see. You don't see a lot of them in 12B because the original curriculum that we borrowed was pre-calculus 12, and we just kind of cut it in the middle. So it's split. whereas chemistry is a whole other thing. So there's not a lot you're going to see. You're going to have to worry about logarithms and exponentials and trig in calculus. If you were planning on signing up for it, I would suggest you do because it's applications of the basics. You will be fine. At least the three of you. I know it's going to boil down to work. Next year may end up being a little bit more work than it normally would have been because you didn't have the practice time, the amount of, and that's where people are going to miss. But other than that, that is all I have. And whoever you have for 12B in calculus will take into, it's the same as chemistry. We got documents, things to focus on because people miss different things. The fact that you didn't get as in-depth of an education in this stuff, it will be taken into account, so I wouldn't worry too much. But that's all I've got for now. And finish the assignments as much as you can. If you don't do all of it, it's not the end of the world if you've got everything else done. And that will be that. If there's no questions.
Okay. That's my dog.
He wants to go outside and play in the sun. Poor fella. Well, I will. I mean, I don't know when I'll see anybody. If you have questions, you can email or post on the kind of thread or whatnot. But other than that, that's all I've got to say. Oh gosh.
Mr. Legier, could you call into the office, please?
Sorry.
Mr. Legier?
Now the PA is coming back, so yeah, this is going to be spectacular today. All right, have a good day. We'll talk to you later.
Bye, Mr. McKay.
Bye. You're welcome.